Hi, I'm Roger Palmer. This is PASCO Scientific. We're going to look today at diffusion. Have you ever wondered how a plant can get all the material that it needs? I mean, sure, if you got a little weed or something and you want to just bring some material from the ground upward, but think about a tree and how much water it has to pull up from the ground sources all the way to the top, hundreds of gallons a day. So diffusion mediates all the processes that happen inside of a cell. And we're going to take a look at that process today in a simple model with a salty solution, as a matter of fact. But the way we're going to test to see if diffusion happens is we're going to see if we can take some types of molecules and move them across a barrier that's semi-permeable, that has little holes to allow certain things through and to keep other things from not passing through that. And we're going to test them with some of the equipment that we have today, from a conductivity sensor, a pH sensor. We're going to take a look at one of the dyes to see if it can move across that barrier using a light sensor. And with that, we'll be excited to take and look at that process so that you can understand how plants move the nutrients they need in order to grow the food that we're looking at. So we're going to take a typical salty solution, saline solution, that's got ions in it. That's pickle juice here. One thing that's true about the pickle juice is one of the ways we're going to test it is a little bit too concentrated, it's too salty for that sensor. So we're going to add about 50-50 water and pickle juice. So I'm just going to add, I've got 50 mils in there right now. I'm going to add enough, so as a matter of fact, we'll just take this off and we can put in 50 mils of water. It brings it into the more accurate range of the conductivity sensor and will work just fine. It still gives great, gives great results. And then this is ready to be tested. You're going to test this with a couple of different instruments that we're going to use. The conductivity sensor. I'll go ahead and take the end off of that. I'll turn the conductivity sensor on. Make sure that it's beeping. I'll put that into solution. We're going to use and test the pH. And that's with this pH sensor. And I usually take the bottom off. If my students are using this in lab and we're not doing too much with it, I'll leave the sensor on and you can push that up if you'd like. You can remove it off as well, but it's just as easy to keep it there so it doesn't go missing. So I'll put it on here and turn that on. Make sure that the light is blinking, which it is. Okay. And the third way that we're going to test this solution is how much. You'll notice the pickle solution is kind of green and yellowish, and that means that it's allowing that yellow side of the Roy G. Bivs, the spectrum, the red, orange, yellow sort of side, it's being absorbed. So the green and the blue is what's being taken out. So, sorry, the red and orange, yellow are coming through on the yellower side. So we're going to take a look at the blue light and how that's being absorbed out of here with our colorimeter. So I'm going to take a sample from here with just an eyedropper. We're going to fill this up the top, put a little cap on that. Okay, we'll put this cap on here. Now, each of these instruments, you should make sure that that they have been calibrated, and the directions for those are in the hands or the booklets that they come with, or you can look at PASCO.com under the documents page so that you can make sure that you're reading these correctly for the conductivity sensor, pH, and for the colorimeter. Once that's done, you're going to go into SparkView, and in SparkView there's a setup for the diffusion lab, which you will see will lead to a display page that's showing the units that are going to be for the pH, units for the conductivity, and for the absorption of the light that's being absorbed out, the blue light that's being absorbed out. We're specifically going to look at that. Now, while you're about to do those, it's probably just as well because it takes a little time for the diffusion tube, the dialysis tubing here. We've been soaking this for about 30 minutes, 20 minutes, just to get it nice and wet, so that we're going to put that solution into this tube. Now, it's a little tricky at the first, so you just have to sort of, don't get impatient with it because it does take a little bit of working. You just rub it back and forth. It doesn't take force. You just need to keep doing it until it opens up. Now, that's going to take a second in terms of filling these. There we go. It's starting to open up like that. You'll notice it'll sort of give an opening at the one end, and then what I'm going to do in the other end is I'm going to tie that off. Now, this is a little tricky. I'm going to just twirl it more like a string because it's much easier to tie if it's more like a string, at least in my hands it is, and I'm sure in your students as well. So we'll just twist that tip like that. Okay, and then I'm just going to wrap it around my finger and try to get that to come through. Just a half a knot is all that's needed. If you need your little pipette here, I think I can push that through. That'll guide it. Or if you have the pipette's nice, and it is just pickle juice, so you don't have to worry about necessarily getting on your hands. But tie a nice half knot there, and I'll give it a nice tug. Now, just to make sure we're going to make it nice and clean fit, I'm going to just snip that end off there so we don't have anything that's hanging on. So I'll put that scissors back over here. Now we're going to fill this with about 20 mils of solution. So, and that's really kind of a guess. It's hard to pour in there, so again, it's good to have a little pipette that I can get it into the top. And we're going to just sort of help that out by pushing that down there. It takes about 6 big squirts of this pickle juice to go in there. And again, I would suggest doing this before you measure, because this is going to take probably the most time. It'll have to soak in just distilled water. We're going to see if we can't find that some of the molecules inside of this can diffuse out. There we go. That looks like a nice amount. Maybe one more. This was only 4. We're trying to get about 15-20 mils in, and I've compared that to here. So I've got a nice bit of solution. I'm going to take this in now. We're going to tie that off by making, like I said, this into sort of a string. It'll just make it far easier to tie. So I'm just twisting it. Okay, and that will give you a chance to make an easy little knot. All right, and then I'm going to put this into a little jar. Let me clip the end of that off. And we're going to put this into some distilled water. So I've marked these each. This is going to be the distilled water, and I've got one that's marked for the pickle juice. That's the inside. And this is going to be the material after we do the diffusion. We want to see what's changed. So we're testing the pickle juice here before the diffusion. I'm going to put some water into this. And as a matter of fact, well, let me put the water in first. So here's my distilled water container. About 60 mils or so. Enough to soak in there. All right. Now, before I put this in, I've been handling it, and I've been putting some salt and whatever else on the surface of this. So I'm just going to go ahead and rinse that outside. Put that back in there. Rinse the outside off just to clean it up. Make sure I haven't left any salt from my hands in there. And we're going to put that into that water to start diffusing, because it's going to take 40 minutes, half an hour, 35 minutes is what the lab, I think, is suggesting. So if you start it now, before you start to measure, that'll be just a good way to keep your students busy. Okay, we'll start that and show you the data collection here in just a minute. Now that you've got your program prepared and you've got your solutions out, we've got our probes that are each into the solution. I'm going to go ahead and take my pickle solution right here, and I'm going to put that into the light sensor colorimeter. If you hadn't yet, go ahead and make sure that you're connected through the Bluetooth device in the top. And you can see all my probes are connected, all my instruments are reading. What you can do is see at the bottom that they are giving you live feeds, so that I have some values in each of those. What I'm going to do is just go ahead and hit start. And this is measuring what the pickle juice and the concentration of that juice are before you do any kind of diffusion. Okay, I'm going to let it run for about, I'd say 20 seconds, just to make sure, and then look at your numbers to make sure that they're sort of leveling out. Sometimes when you first put the sensors into solution, they may, just coming into equilibrium with whatever solution that's going on. So take a look there. Okay, the pH looks pretty good. Okay, conductivity, again, that's about 14,000, and that's under 20,000 is what we want to keep that solution for its most accurate range, and so that's why we added a half a volume of the water with the pickle juice. And then the last one is how much the absorption of light is there. So the absorption, blue light going through that pickle juice is 0.33. All right, well, there's the measurement that we need, and now what we're going to do is wait for another 40, let me stop that. We're going to wait for another 40 minutes or so while this is soaking to see what happens to it's sitting in distilled water, and on the inside is the pickle juice. And we're going to watch the process after 40 minutes to see if there's been molecules moving from outside in the distilled water into the solution, and then any molecules from the inside of that dialysis bag out into solution. And we'll test those two solutions here when we come back in about 40 minutes. All right, it's been 40 minutes. Let's take our solution now. We've got two solutions we want to test. One is the water that's in here to see if there are molecules moving out of the pickle juice and have gone into here. We're going to test that solution. And we're going to take this pickle juice and we're going to cut the tip and put it into here. So let me cut the top off. And we're going to save that pickle juice to sense, just like we did with the solutions that are just to the side of me here. So, okay, awesome. Now, we're going to test that solution first. We see what our values were on the previous juice. I'm going to go ahead and just rinse these off. I'm going to rinse them off into here. It's just pickle juice, so I'm not too worried about that. Okay. And let's go right into this little container here. Make sure that I've got enough that it's covering the bottom of the pH sensor and that the two little metal probes of the conductivity sensor are there. So it looks like, yep, those values have changed a little bit. And now I'm going to take out this solution. And this is just distilled water, so let's pour that into here. Okay, I'm going to take some of this solution out. Yeah, let's do that. Okay, it only takes 2 or 3 little squirts in there to make that happen and fill it up enough so that we can get the light through. I better put one more in and make sure that there's enough solution in there to sense, both for the sensors here and for the light path through there. Okay. Now I'm going to go ahead and just look real quickly at my my version of SparkView going here and just kind of remember a little bit of what those numbers are. 3.5, 14,000, and 0.34. I'm going to go ahead and hit the start again. Okay, so 3.4 moved up to 3.8, 3.7. We had about 14,000 is down to 3,000. And the light went down a little bit too, from 0.3 to 0.25. So that's in the pickle juice. We've seen that what makes those molecules that do the absorption or cause the pH are becoming less concentrated. Okay, I'll let that run, like I said, about 20 seconds or so just to get good stability on all 3 of these measures. So that's fascinating. I'm going to go ahead and I'm going to rinse these guys out again to go into the now distilled water to see if any of them went out of the dialysis tubing and into this solution. I'm going to need another cuvette here, as long as that's, I'm going to dump that off screen here. There we go. I'm going to rinse it once. There we are. And let's take a sample of this water in which that dialysis tube was sitting, and we'll see if any molecules have diffused out. Okay, let's put that in here. All right, I'm looking at the bottom, and I definitely have an interesting range of values. This is now in the water itself. I'm going to go ahead and hit the start. This will be our 3rd little run. Okay, the pH here of water is affected. It's acidic. You can see it's 3.7. I would expect, water to be more close to 7. It might be as high as 8 if you've got water in areas that are you have limestone around or have ground limestone in your soils, the center of the United States, and it might be maybe 4 or 5 if you're in areas that have like acidic rain or something. But the conductivity here, there definitely is some conductivity. Most streams, if it were very clean water, would be more in the hundreds. And then we've got the last one of how much of the pickle dye is in there absorbing blue, and we have almost no absorption. So just as comparisons there real quick, and we'll talk about those in more detail here under analysis. All right, now that you've taken your data and you've put those into the places appropriately on the data sheet, what you're going to do is take some time to take a look at how the concentration of the molecules that were in the pickle solution were moving. What we started from, you had some initial readings, okay, and we had some pretty high conductivity. We had a lot of that green sort of, yellowish appearing, but we tested it with blue light. So it was absorbing a lot of blue, letting the yellow and the green sort of side of the spectra come through. And we tested its pH, which is acidic. And most pickles that would come out have a little bit of vinegar in them. Vinegar is acetic acid, so we did expect them to look a little bit more like acid in that range. Now, the big question is, once they are inside of something like our dialysis tubes that we had, were they able to move across these barriers? Okay. And in diffusion, that's the most important part as we talk about a plant being able to move nutrients or the materials they make, like the food that's being made in the leaves during photosynthesis, from those areas to other areas of the plant. So we want to see, do things diffuse across that barrier and either into the remaining distilled water, or did some of that water only diffuse into the dialysis tube, so that we would see that this got weaker if there was more water coming in. You're going to do that analysis by looking at those values in the PDF that we provide. You're going to see we had 3 different tests, and each one tests something a little differently. The acetic acid from the pickles are going to be detected by the pH sensor. Okay, the salts that might be in there, the conductivity, the things that can carry charge, are going to be tested by the conductivity sensor. And then the large molecule, that is the dye that's put in there, it allows the yellow and green lights through so that you see it, and we measured it by saying it absorbs blue. So we have 3 sort of size molecules we're looking to see if they made it across. That's going to be critical in what you look at from the pickle juice that's been inside of the dialysis tubing. You're going to see, did it get less concentrated as it went here? That means the water is moving in. And then in the water, you're going to say, did some of this, either the saltiness, the dye, or the vinegar, move out into the solution? Okay, so if that's the case, if dye is moving out, you'd have seen more blue absorption. If the pH of the water goes more towards acid, that means the acid came out. And then the last one is if the salt was making its way out, you'd seen a dramatic rise in the conductivity. So take a look at those numbers, and when you write up your lab for your analysis, you're going to talk about which way materials are moving, in or out of the dialysis tubing, now that we've studied these regions. Good luck with your analysis, and looking forward to having your answers be turned in. Have a great day.